This is the introduction to section 4.5, part 1, and we're going to be dealing with isosceles and equilateral triangles. And we've talked about triangles in the past, so this is nothing new. It's just now we have a couple of specific types of triangles, and many of you have seen this before. So this is not going to be anything that's overwhelmingly new or complicated here. Our objective here is to use and apply properties of isosceles and equilateral triangles. Okay. Isosceles triangles are common in the real world. You can frequently see them in structures such as bridges and buildings, as well as in art and design. Okay? The congruent sides of an isosceles triangle are its legs. The third side is the base. The two congruent legs form the vertex angle, and the two other legs form the base angles. Okay, so let's take a look here at this picture real quick. An isosceles triangle is a triangle that, essentially the definition is, a triangle that has two congruent sides. Okay, and these sides are what we call the legs. These are the two congruent sides, and that's what the arrows are pointing here for. Okay, the other side is what we call the base side, and the base side also has what we call the two base angles. Now, the base angles are opposite of the sides, so these two base angles are opposite of where those sides are at. So the two base angles here, as you can tell, are on the bottom in this case. Okay, those are the two base angles, opposite of the congruent sides. The vertex angle, the one angle that's left out, is what we call the vertex angle, and that's formed by the two congruent sides where they intersect. Okay, so the vertex angle is where the two congruent sides intersect. So this kind of talks a little bit more about isosceles triangle. Now, we've got two theorems here as well. We've got the isosceles triangle theorem and the converse of the isosceles triangle theorem. Yes, you are going to want to add these to your tool belt as we're going through here. So take out your tool belt and add these to it because you are going to use these in proofs. So the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay? So in other words, it says if AC and BC are congruent, the two sides are congruent of a triangle, then the two angles of the triangle opposite of that are congruent as well. Again, these angles are opposite of the sides. Okay, so angle A and angle B would be congruent to each other. Now, the converse is like the flip of that. Okay, so now I'm going to say if two angles of a triangle are congruent, then the opposite sides of those angles are congruent as well. So, if I say angle A and angle B are congruent to each other, then the sides opposite of those angles are congruent to each other as well. That's the converse of the isosceles triangle theorem. Okay? All right, so those are the two theorems that you're going to look at here in this section. Okay, a corollary, again, terminology here. A corollary is a theorem that can be proved easily using another theorem. So essentially a corollary is an add-on to a theorem. Okay? Since a corollary is a theorem, you can use it as a reason in a proof. So again, these are two things that you'll want to put down in your tool belt. All right? And if you want to call it something a little bit better, instead of theorem 4.3, you could say that this is the equilateral triangles theorem. Call it that. And this would be the converse of it. Okay, that'd be the converse of it. So what the equilateral triangles theorem says is that if a triangle is equilateral, then the triangle is equiangular. Equilateral means that all the sides are congruent to each other, all three sides. That's what equilateral means. So if all three sides are equal to each other, then all three angles have to be equal to each other. Okay? And the converse of that says then if all three angles are equal to each other, then all three sides are equal to each other. Talking about equilateral triangles. Those are make sure that you put those in your tool belt. Now, let's go through a couple of examples here. Okay? So it wants to know what is the measure of angle A. Well, as you look at this triangle, this is an isosceles triangle, and you know, since if you have an isosceles triangle, that if the sides are congruent to each other, the two sides are congruent to each other. The opposite angles are congruent as well. Well, the opposite angle is 70 degrees. So angle C is 70 degrees. That's one of the base angles. The base angles have to be congruent in an isosceles triangle, so therefore angle A is also 70 degrees. And that's what you're looking for. Okay. Now, if I ask you to find the measure of angle B, if you know both of these are 70, then 70 and 70 is 140. And what has to be left over? Well, angle B would have to be 40 degrees because the three angles of a triangle add up to 180. Okay? All right, now what I would suggest you do here, again, you're going to find the measure of angle A, but I also want you to find the measure of angle B once you find A. Hit pause, come up with your answer, and then see if you have it correct. Okay, now that you've hit pause and you went through the answer, let's take a look here and see what this actually is. Now, you'll notice that the angles here have the same marking, so this one's actually pretty easy. Angle A has to be 53 degrees. Well, if angle A is 53 degrees, 53 and 53 is 106, which means that angle B would be 74 degrees left over, or 180 minus 106. Okay? These are the types of things that you're going to be looking at on homework, okay, in terms of practice problems. Let's go through one more example here now. Again, hit pause and see if you can find the value of x. Okay, now that you're back, let's take a look and figure out how to complete this. Now, you'll notice this is an isosceles triangle again, and this right here is a base angle. That's x. Well, we don't have a marking here, but if that's x, then this base angle also has to be x. And if I add the three together, they have to equal 180 degrees. So in other words, 2x is going to equal 150, and x is going to equal 75 if I solve it. Okay. Now, what some of you may have done is taken 180 minus 30, gotten 150, and divided in half, which is essentially divided by 2, which is essentially what you did in the equation to get the answer. Okay, this concludes section 4-5, part 1. Don't forget to complete your WSQ.